Good time of the day, everyone. My name is Danial. I'm 12th grade student, and I have mathematics analysis and approaches on higher level as one of my TP subjects. In this video, I will be talking about binomial theorem and extension of the binomial theorem. One of the topics of the unit number 1, numbers and algebra. Before watching this video, it is addressed to know the topics on how to use the combinations as well as factorization. And additionally, this is a continuation of this video you're seeing right now on this channel, and it is recommended to watch it beforehand. So let's get back to the topic. I'm sure everyone who watches this video knows how to open the brackets. So a plus b in the first power is a plus b. A plus b in the second power or in square is a squared plus 2ab plus b squared. But do you know what polynomial we will have if we increase the power to the 3, 4, and 5? I'll give you 5 seconds on this one. You can stop video if you want to have more time, but I am showing the answers. So this is the answer for the cubic polynomial. A cube multiplies 3a squared b plus 3ab squared plus b to the third power. And this is the answer to the fourth power and to the fifth power. Watching these results, you can see some pattern among them, but in this video you can see the pattern much clearer and understand what pattern do they have. But before that, I want to show you about the Pascal triangle. So the numbers in the Pascal triangle have some connection with the binomial coefficients. But what is a Pascal triangle? So Pascal triangle is a triangle in which the number from the upper row that is nearest to the square itself, when adding together, they create a number. So for example, you can see on the second row that 1 plus 1, they're the most near squares on the upper row, and when they added together, they create the 2. Another example, 1 plus 3, they create 4, and 6 plus 4, they create 10. But anyway, back to its connection with the binomial theorem. So, as I said before, it has some connection with the coefficients, and the number of row shows the coefficients of the power outside of bracket plus 1. So for example, a plus b squared, we need to look to the third row, because 2 plus 1 is 3, and we can get 1, 2, 3, 1 to 1. On the third row, we get numbers 1 to 1, and they're the same numbers here. A squared have coefficient 1, AB have coefficient 2, and B squared have coefficient 1. Similarly, the same situation can be seen in the A plus B in cube. And the fourth row shows the coefficients 1, 3, 1, 3, 1. And here we can also see 1 multiplied by a squared, a cube, 3 multiplied a squared b, 3 multiplied a b squared, and 1 multiplied b cube. So you can see it itself, and if you want to know the coefficients on the when opening the brackets, you can use the Pascal triangle to know which coefficients you need to write when opening the brackets. And this is a formula for the binomial theorem. So binomial theorem is a theorem that is used to represent the opening the brackets. Sometimes it is called the binomial expansion. And as you can see in this formula, it shows the general formula for the opening of the bracket. So for any number a plus b in the brackets outside the brackets n to the power n, this is a common formula. So it is a to the power of n plus one combination out of n to the power of a n minus 1 to multiplied b, and so on, every the next term. The combination coefficient changes, but every other term is a times less, but b times more than the previous term, and it goes until it becomes b to the power of n. So as you can see, first and last term, they're without the coefficients. This is due to they have coefficients in fact, but due to them being 1, we do not write them. And this only works for the n, the power of n, that is natural number. In other words, when n is positive whole number. And let's make some practice for the better understanding of the topic. So we have the first exercise, a in the brackets a plus 0.5b to the power of 6. So in this case, to save the space, instead of 0.5, I will be using the 1 divided by 2. And firstly, we need to open the brackets itself to the binomial theorem, and we get 1, 2, 3, 4, 5, 6, 7 terms. And these terms will be changed a little bit. For example, we show the coefficients as numbers, and after that there is the answer. You can see it's a big polynomial, and you can check by yourself if you got the same answer or not. And the second exercise, similarly, we firstly open it by the binomial and just simplify it until we get the answer of 16a to the fourth power plus 32a cubed plus 24a squared plus 8a plus 1. But let's talk about the extension of the binomial theorem. So when opening the brackets, you can see that in the form a plus b to the power of n is not always natural number, it's not always the whole positive number. So when you try to use the binomial theorem, it seems that it is impossible, and this is because, yes, it doesn't make sense. So for example, 0.5 CR, when using the combination formula, it doesn't make sense, even when thinking of it as just example. Overall, we have, for example, 0.5 students, and we need to choose one student to go to the Math Olympiad, or the same situation but with -2. Both of the situations, it doesn't make sense because the answer is not whole, and it is a little bit strange. As you can see, even the calculator, it shows that I'm trying to do it when instead of n we use not natural numbers, it shows the error. And for the situations when the n is not natural number, with the extension of the binomial theorem. So what to do? So we just need to use combinations formula. Let's wash it, and it is equal to the n factorial divided by r factorial multiplied n minus r factorial. But if we open up the factorials, you can see that n factorial can be simplified to the n multiplied n minus 1 multiplied n minus 2 and so on, multiplied n minus r plus 1 multiplied n minus r and so on until it gets to the 1. And similar to that is n minus r factorial. But as you can see, we can just simplify it because it doesn't change anything. So we can just get rid of these two terms, and we would just get the n multiplied n minus 1 multiplied so on until multiplied n minus r plus 1 divided by r factorial. And in this case, due to r always being the positive number in the binomial theorem, and the only n being non-natural, we can use this. This equation because it doesn't contradict anything. So, for example, if we try to do nc1 for any number, so it will be equal to n divided by 1 factorial or n. Why we use this equation? Because the last term n minus r plus 1, it should be equal to the n, because if r equal to 1, it will be equal to n minus 1 plus 1, which is equal to the n. So first term is n and last term is n, so that's why the whole equation will be equal to n. Similar task should be done with nc2. R is equal to, so n minus 2 plus 1 is equal to n minus 1. So first term is n, last term is n minus 1. So we can only use two terms, and it's all divided by 2 factorial. And we see the answer on the screen itself. And the same situation can be done with the third equation, nc3. Same one, the last term is n minus 2, and we get n multiplied n minus 1 multiplied n minus 2 divided by 6. And it's no, it doesn't matter if n is positive number, negative, whole or not whole. It doesn't matter if the n is any number, any irrational number. It doesn't change anything, so we can use this type of equation instead of NCR in the calculator. So the extension of the binomial theorem, we can use this form 1 plus x to the power of n, and you can see that it's equal to n plus nx. As you remember, nc1 is equal to n, and you can see that nc2 is equal to this number and this term and so on, but we can use this extension for the binomial theorem to open the brackets when the n is not whole positive number. But this polynomial for non-natural n is infinite, as you can see in the formula, and even if you think about it, it should be infinity because there's no limit to what numbers it can be. But if instead of 1 plus x we have two different numbers and both of them are not 1, we can simply make it so it would be 1 plus x to the power of n. So firstly, we need to divide a from the rest of the equation. So firstly, we divide both parts of a and b to the a. So we will get a multiplied by 1 plus b divided by a. And everything is in the nth power. And then we just divide a times n, and 1 plus b divided by a times n. And let's say, for the sake of the equation and making everything a little less difficult, b divided by a will be x. So we'll get a times n multiplied by 1 plus x to the power of n. And this is a whole extension of binomial theorem for any number, even if the n is indeed natural. We can still use this formula, but for the natural n, for the n when it is natural, it is simpler to use the binomial theorem. But if n is not natural, we can only use this xn formula. And as you can see, it's just the same formula as in the parent part, but just with a in the power of n outside of the brackets. And similar to the before, let's make practice problems again for the better understanding of the concept. So I'll count to 5, but if you want more time, you can just click to the pause button. 1, 2, 3, 4, 5, and let's get back to the problem. So first problem is 1 plus 2x to the power of 0.5. And in this case, we have n as 0.5 and x as 2x. So we can use the formula 1 plus x to the power of n. So opening the brackets, we will get big polynomial, and we have 1 plus nx, n is 0.5 and x is 2x, plus n multiplied n minus 1 divided by 2 factorial multiplied to the x squared, and so on, so on. The polynomial is infinite, and we'll get the answer of 1 plus x minus half of x squared plus half of x cubed minus 5/5 of x to the power of 4, and so on, so on. The polynomial is infinite, as I said before. You can just write the first 3 or 4 terms, but if the question itself asks for more terms, you will write more of them. But mostly the question itself asks only for 3 or 4 of them. And the second one, 2 plus x to the power of minus 2. So the n is minus 2, but in this case we don't have 1. So that's why we will be dividing both 2 and x to the 2. So outside the brackets we'll have 2 to the power of minus 2 multiplied by 1 plus half x to the power of minus 2. And we'll get half quarter multiplied by this big polynomial we get from 1 plus half x to the power of minus 2. And simplifying it and then multiplying to the quarter, we'll get the answer of quarter minus quarter of x plus 3 divided by 16 x squared minus 1 divided by 8 x cubed plus 5 divided by 64 x to the power of 4, and so on, so on. To not get confused, make the main brackets a little bit different colors, so it will be easier to understand the equation. And now let's get back to the past papers. Past papers is the is the exercises that we're getting from the paper 1 and paper 2 that were on the exam of the previous years. So the first task asks us to expand the 2x plus 1 to the power of 4 in descending powers of x and simplify your answer. So this is pretty easy task. So we just use the binomial theorem formula, and we'll have 2x to the power 4 plus 41 multiplied by 2x to the power 3 multiplied by 1 plus 42 multiplied by 2x to the power of 2 multiplied by 1 square plus 43 multiplied by 2x multiplied by 1 cube plus 1 to the power of 4. And simplifying everything, we will get that the answer is 16x to the power of 4 plus 32 to the power of 3 plus 24 to the power of 2 plus 8x plus 1. This is on the easiest half of the past papers, but the second one is a bit trickier, as you have x outside of the brackets, and we need to find the a with a constant term of 20,412, and in this case we don't need to know all the terms, but firstly we need to write what it should be like. So it will be x multiplied by this term to the 7th power is equal to the several terms, and there we have 20,412, and we divide both sides by x, and we'll have that we need to find how from these brackets to the power of 7 we need to get 20,412 x to the power of minus 1. So to get x to the power of minus 1, we need to multiply x squared to the power 2 to the x to the power of minus 1 to the power of 5, and 2 multiplied by 2 is, so we have 2 and 5. 2 plus 5 is 7, and 7 is outside of brackets, so we need to multiply 2x squared 2 times and a divided by x 5 times to get the x minus 1 with a coefficient of 20,412. We'll get that using the binomial theorem. One of the terms should be like this, and we'll get that r that we're finding r is 5 due to the, again, 20,412, it should be equal to the 7 cr and multiplied by a divided by x to the power of r multiplied by 2x squared multiplied of to the power of n minus r, and we'll get that so we erased all x's, and we'll get that 20,412 is equal to the 21 multiplied by a to the power of 5 multiplied by 4, and we'll get that a is equal to the 243 to the power of 1 divided by 5, and a is equal to the 3. That's the answer. And now another two tasks. Consider the binomial expansion of 1 divided by square root of 9 minus 3a and write down the first three terms. So in this case n would be minus 0.5. We can rewrite the expansion as 9 minus 3a to the power of negative 0.5. The n will be negative 0.5. And to use the formula 1 plus x to the power of n, we need to divide 9 to the 9 and minus 3a also to the 9, and we'll get that 9 to the power of negative 0.5 multiplied by 1 minus a divided by 3 to the power of negative 0.5. We can rewrite a divided by 3 as x for the simplification, and we'll get that 9 to the power of 0.5, negative 0.5, multiplied by 1 minus x minus to the power of minus 0.5, and we'll get that 1 divided by 3 multiplied by this big term. We can use the expansion of binomial theorem to rewrite the 1 minus x to the power of negative 0.5, and we'll get that and after we multiply to the 1/3, we'll get 1 divided by 3 minus 1 divided by 6x plus 3 divided by x squared, and so on. But if we again change x to the a divided by 3, we'll get 1 divided by 3 minus a divided by 18 plus 1 divided by 24 a squared, and so on. But we only need first 3 terms as is written in the task. And the next one, use the fractional binomial theorem to show that x divided by 1 plus x squared is approximately equal to the x minus 2x squared plus 3x cubed, where x model of x is less than 1. So in this case, firstly we need to rewrite it again, and it will be equal to the x multiplied by 1 plus x to the power of negative 2. So again, use the yellow red brackets for better understanding of what is written here. And again, we use the expansion of binomial theorem formula, where n is equal to the negative 2, and we get x multiplied by, in the brackets, 1 minus 2x plus 3x squared minus 4x cubed, and so on. But we only need first 3 terms, and if we multiply what is outside of brackets and inside of the brackets, we will get x minus 2x squared plus 3x cubed, and so on. And again, they're the same 2 numbers, so that's the answer. And don't forget to show and explain that due to x in model being less than 1, the next terms with higher power of x become negligible, so that's why we only need first 3 terms. And that's why the task asks us to show first 3 terms. And that's the end of the video. I hope this video lesson was helpful for you. Good luck on your exams, and goodbye.